Hello, and thank you for taking the time to watch this DTOceanPlus video, where I'll discuss how the DTOcean project looked to address the sector needs, innovation of ocean energy systems. My name is Inès Tunga. I'm the Renewables Practice Manager at the Energy Systems Catapult. To meet these sector needs for innovation, we at the Energy Systems Catapult led the work on developing the structured innovation tool for concept creation and selection for ocean energy systems, and this was part of the Horizon 2020 DTOceanPlus project. Now, we know that the ocean energy sector can contribute to transitioning to a decarbonized whole energy system and achieve the net zero commitment by 2050 and beyond. Some of the recent reports project that ocean energy could reach 10 gigawatts of installed capacity by 2030 and complementing other renewables with features such as predictability and diversity of supply. With nearly 55% of the world ocean energy resource potential across the UK and Northwest Europe, the ocean energy sector could play an important role in delivering economic recovery and also addressing the decarbonization challenge. However, cost reduction are still required for this technology to be commercially competitive. As with most mature technology, radical innovation at early stages of development is needed. This is to address technical challenges in achieving sustainable, affordable, and secure electricity to the market. The picture on the right there shows a resource map of Europe with the legend showing in the dark blue, we have the wave resources and projects, locations. We have in red, we have the tidal, and in light blue, the wave and wind project as well. In more mature sectors, most companies developing new projects, new product or services use a form of innovation process to identify, create, and develop innovative solutions. This is seen across a wide variety of sectors. An example is the automotive industry or the aerospace as well. In the ocean energy sector, however, the adoption of such methodology is less evident and less advanced as well. The lack of a standard structured approach to innovation makes it difficult to impartially analyze innovative design. It renders it impossible to objectively compare competing technologies, and it can also lead to functional fixedness. So the structured innovation tool within the DTOceanPlus suite of tools that we have developed is to meet the sector need for innovation by supporting concept creation, selection, and design of ocean energy systems that includes subsystems, energy capture devices, and array. So the tool integrates a combination of simple and common, well-known approaches to thinking about the element of a particular problem, which then form the basis of a systematically innovating and generating new ideas. The tool is intended to provide the designer with a process, with information, with validated data, analysis, and comparative assessment. The tool will provoke the designer to consider the interaction between all the various technical solutions to a problem and the necessary compromises that are required to meet the design intent. So it enables careful, structured approach to enable all optimistic innovation, as well as that created by that systematic thinking. So the structured innovation tool that we are talking about is developed using the QFD, which is Quality Functional Deployment Methodology, TREES, translated as Theory of Inventive Problem Solving, and a well-known risk mitigation methodology called FMEA, which is the failure modes and event analysis. The aim of this integrated tool is to provoke innovation and help represent the voice of the stakeholder, to allow the designer to understand the art of the possible beyond the state of the art for concept targets. It enables objective comparison between various technologies, It enables systematic thinking for design beyond the current state of the art, and it gives development guidance or direction and impact. Through this video, I'm going to return to the sector need for innovation and how the capabilities of the structured innovation tool can support the various stakeholder needs. This slide here highlights key stakeholders that can benefit from the DTOceanPlus suite of tools and the design objective that they potentially look to achieve. These stakeholders are mainly technology or project developers, public funding bodies, and private investors. We also have a wider group including policymakers, regulators, standard bodies, insurance, and the various supply chain. Now, two examples are provided here. On the right-hand side, highlighting the application of the structured innovation to support developers in improving existing design is one of the Core Power Wave Boost project that looks to increase reliability and survivability of the wave energy converter to increase performance and reduce cost of the device. And on the left-hand side of the slide, highlighting the application of the structured innovation tool to support development of new concepts is one of the Interreg project called ITEG, integrating tidal energy into European grid, looking to develop an all-in-one tidal energy and hydrogen production solution to tackle grid export limitation faced in remote communities. The following slides will present the capabilities of the SI tool or the structured innovation tool and how the tool can meet the various stakeholder design objectives. These objectives vary between evaluating different system level concepts, identifying the most promising investment potential to reach innovation target at least possible cost, to identify areas of innovation to improve within a technology, or to carry out gap analysis and identify enabling technologies. So the structured innovation tool comprises of 5 functionalities, with the features presented in the following slides, a brief walkthrough of the tool. I should note here that the tool relies on the input of cross-functional teams and multiple disciplines with comprehensive view of the sector challenges. So the first step here of the tool is to define the objective of the study. This step captures the project objective and list of stakeholder needs. In the context of developing a new product, for instance, this is a list of all the key stakeholder requirements. The requirement of multiple stakeholders could originate from market research, interviews, law and regulations, contracts, operational modes, site conditions, etc. But they can also be the result of designer needs, where there's some design limitations, risk mitigation measures from FMEA outputs, or the art of the possible, ideal technology values rather than state of the art. These requirements are often general, they are vague, difficult to implement directly into a solution. So they need to be refined, grouped, prioritized in order of importance. Again, as mentioned, this is mainly done by the group of multifunctional and cross-disciplinary teams. And an example here on this slide shows the various types of customer requirements or stakeholder requirements. The example from funding bodies like Wave Energy Scotland to different calls looking at how to develop technologies, as well as new concept, how to bring in storage solution to existing solution, for example. So the next slide here looks to, once the stakeholder requirements are well defined and prioritized, then the tool is then used to, the step following that to map the key parameters that we call functional requirements relating to ocean energy concept to meet those stakeholder needs. Once the customer requirements are translated into functional requirements, they are ranked into attractiveness through high-level physical and economic assessments. So the QFD, the quality functional deployment, is used to capture and prioritize those requirements and translate them into functional requirements. What the tool also does, it allows the designer or the team of designers here to understand the strength of the relationship between the needs and the functional requirements. It also enables the user to establish the interdependencies between the functional requirements, gaining insights into the various conflicts between the requirements. That then leads to identifying and solving those conflicts using another methodology called trees that is integrated into the tool. And trees use a library of problems and solutions, various tools to identify areas where there's a trade-off needed and resolving them using the different libraries of inventive principles. Now here on the slide, there's some examples of external tools such as the scenario creation tool or the fundamental relationship tools. These are external tools to the structured innovation tool that can be used to guide the designer in defining relationship between the functional requirements and combining various parameters to create possible and attractive scenarios. This slide highlights the subsequent steps, including competitor benchmarking, ideality assessment, organizational impact. I'm not going to go into a lot of details, but all this information will be available in the documentation as well as on our website. And any question are welcome during the workshop as well. So these steps here are followed by the step for risk mitigation using the failure mode and event analysis, the method, the FMEA. And this allows to identify potential failure mode for each requirement and determine mitigation measures to remove or reduce the potential for failure. And after a long iterative process done by a team of designers, the user gets to the end of the process. The output of the tool includes critical, most impactful functional requirement with the highest overall impact and the least organizational effort to implement. The output of the tool also provides value-added areas beyond the current state of the art that can contribute to the intended targets and the stakeholder needs as well. So the structured innovation outputs are there to benefit the various stakeholder design objective. And the next slide here reiterates the various stakeholders that we talked about and the possible design objective to achieve. Excuse me. So in conclusion, the structured innovation is a tool provided to different stakeholders to support the different design objective. The tool has been designed to use in standalone, but the value added is when the tool is used in integrated mode with the stage gate tool and other design and assessment tools within the DTOceanPlus suite of tools. More information can be obtained on our website in the documentation and deliverable provided. However, we have a Q&A session on the 31st of August where we can answer any question and provide more details as well. Thank you for listening. I hope you found it useful. We look forward to answer all the questions you have. Thank you.